Hi everyone, my name is Natalia Ransolin. I'm a PhD student of civil engineering at URGS. My advisors are Professor Saurin and Carlos Formoso, and I will present our paper called The Influence of the Built Environment on Patient Safety and Well-Being, a Functional Perspective. So the background of this paper is based on healthcare facilities, and we adopted here a concept of built environment requirements. There are building attributes like components, utilities, and space that should be in place in order to work to occur and to fulfill the needs of the end user, mainly the patient. So in a high abstraction level, those requirements can be understood as patient safety and well-being. And there is a major discipline that is named evidence-based design, which supports with evidence from the literature of healthcare facilities, the decision-making and design of those facilities. And there are lots of studies about the contributions of the built environment, like noisy, privacy, and comfort to the patient, to the patient's condition. So the design decisions must take into account those requirements and those conditions to support the flow of activities that are performed in those healthcare services. So to support better those healthcare services, it's important that the built environment takes into account the work has done in those spaces to feedback the evidence-based design literature with better contributions. And however, the designers nowadays usually taking into account only the work as imagined by rules and protocols, disregarding those activities that account for the work as done. So in this paper, we used an approach called the FRAM, which is Functional Resonance Analysis Method, to understand the variability propagations in complex systems. And here we used to modeling the interactions between the built environment and the patient in an ICU. This paper is part of a broader research. It was my master dissertation, and the paper from the master was published a couple of weeks ago, and it's called Integrated Modeling of Built Environment and Functional Requirements. And I used FRAM and BIM in order to improve requirements management. So here's some principles of FRAM. FRAM is a model where you can interconnect functions. There are activities performed by caregivers and patients or other agents, and there are corresponding variabilities and the coupling between functions. And each function is represented by a hexagon, where we can represent the 6 aspects that compose these functions. There are input, output, preconditions, resources, time and control. And in this study, the first 3 aspects are the most important, where input is what starts the functions and make it delivers the output for the system. And the precondition aspect is related to the concept of built environment requirements. In the FRAM model, we can also represent the variability as a wave inside of the function, and the coupling between functions, which are represented by the connection between the output of a function with other aspects of other functions, like the input of the next function. And the functional resonance principle is the most important in this study because we use to represent the unintended interaction between the function performed by caregivers in order to cope with system variability. and is in the scenario where we will discuss. And the main assumption of this work is that the variability in fulfilling those requirements propagates to functions and even to the patient. And the caregivers must cope with this variability by performing resilience efforts. And that the variability and the unfulfillment of these requirements is in the precondition aspect that generates this variability. So here are the functional resonance scenario where we will discuss the results. So in green are the functions called care functions. In red are the resilience performance functions, all of them performed by caregivers. The yellow functions are the boundaries of the system and of the analysis. The top one are performed by patients. Its name is respond to care interventions. And the last one is fulfill the requirements. It's performed in the build environment and is performed by the design of the healthcare facility. And it delivers build environment requirements that must be met in order to the functions in green be produced. And when they are not being met, the variability is generated by those green functions, which call the need for resilience performed by red ones. For example, when patients are receiving a care procedure and regular and continuous care, which is usual in ICU. So the build environment needs to provide easy access to the patient area and space to accommodate medical equipment. But if these requirements are not being met, the variability propagates to the system, and the caregivers are constantly adjusting the patient-based layout in order to meet the patient's needs. And another situation is when the patient wakes up before after a care procedure, and he usually are more unaware of time and space, and it's normal that it's almost normal that in an ICU patients present a situation, a condition called delirium, when he is unaware of these dimensions, which is very harmful for their health. So it's important that the build environment requirements provide natural and indirect lighting and individualized and indirect air conditioning, because each patient wakes up with different needs in terms of temperature and lighting. So it can, the unfulfillment of those requirements can contribute badly and negatively to the health conditions. So to cope with this, caregivers are constantly applying sedation to patients to avoid the increasing of the delirium conditions. So some discussions we can have is that the variability in not fulfilling the build environment requirements propagates across spaces and time to everyday functions of caregivers. It can impact on patient safety and well-being. So it's important to us to understand how employees cope with this variability by performing the resilience functions. So it's important to understand the work as done by teams. So however, we have to understand that the resilience may imply in the creation of new functions, thus increasing opportunities for unintended interaction and add more complex for the system. And the traditional design management disregard this work as done. So it's important that we consider the work as done and the resilience effort of caregivers to feedback the evidence-based design literature with the acknowledgement of those inherent variability of complex systems, in order also to improve value generation, supporting the fulfillment of those requirements that impact indirectly in the patient safety and well-being. Here are some references, and thank you very much